Hi everyone, welcome to the video on advanced shapes and arcs in P5JS. This video is going to very briefly cover some of the shapes that you'll see in the reference sheet but that we are not talking about explicitly in synchronous learning together. If you do not care as much about some of these advanced shapes like how to use begin shape or a review of quads and triangles, feel free to skip ahead to somewhere towards the end of this video, timestamp not available yet, and we'll be talking about arcs towards the end. There will be like a fairly deep dive into arcs. I know they can be confusing and they're super useful, especially as you guys are going about your projects for today. So for now, we're going to get started by looking at the P5 reference sheet, and if you don't already have this open, I recommend it. For all code along videos, you should probably have the reference sheet and a blank editor open. At any time during this video, also remember that you can pause to try things on your own, and you can always go back and rewatch if there's something you missed. Additionally, if any of this is just not landing for you, that's why we have office hours, that's why we have the Slack. Please, please, please make sure you are reaching out to a peer or to an instructor to make sure that you can get whatever help you need. So to start out, in the reference sheet, you're going to see that underneath shape, we have a lot of different options. The scope of this class generally just deals with 2D shapes. 3D shapes exist, they're really exciting for students. 3D shapes do not always play nice with 2D shapes, and they can be really confusing for students to access and edit in a way that's meaningful, and so that they can create expressive things the way we want them to during this class. My advice for students whenever I introduce things in the reference sheet is that they are welcome to use anything they find here, as long as they can understand what they are doing and explain it to me. If a student chooses to use something like this box function under 3D primitives and they don't know how it works, or they get it working and then it breaks the rest of their program, I tell them very explicitly that that is not something I am going to help them troubleshoot, since it is not in the scope of our class, and maybe they need to rethink using things that we have already learned that they better understand. So that being said, I'm going to ignore 3D primitives, I'm going to ignore 3D model. I'm actually going to ignore most of attributes. I'm just going to focus in the 2D primitives, some of this vertex work, and we might look at a few of the curves. So first, underneath 2D shapes, you will see that we have ellipse and circle, and also rectangle and square. A best practice, in my opinion, is to only teach students ellipse and rectangle. It's less to remember. Circle and square are both built off of those functions. They just each take one less argument. Circle takes 3 to ellipse taking 4. Square takes 3 to rectangle taking 4, and at least in the case of the ellipse, you can just put in 3 arguments and draw a circle. Normally, in the case of a rectangle, if students just remember that width and height are the same in a square, they can use it to create a square. Things that I'm not sure if we are going to be talking about in class but are pretty straightforward are line. Lines are drawn between 2 points. This can be a little confusing to students who are used to, in the case of ellipse and rectangles, giving a specific size. Here there's no size, it's just going to draw between these points. In the reference sheet, in any of these examples, if you click edit, you can test right in this reference sheet. So right now this line is being drawn between point 3020 and point 8575. If I were to adjust this to, let's say, 0, 0, that should move my line up to the origin up top, and then draw from the origin to 8575. So let's hit run, and we see that that's working out great. I could also shorten this up. I could have this go, oops, I have to edit again. I could have this go to 50, 50, which will be the exact middle of this canvas, which I believe is 100 by 100. And if I now click run, I have a diagonal going 0, 0, 50, 50. This is a great starting place for students who do want to work with more complicated shapes, because this idea of taking in points and connecting them are how most of the other shapes, barring an arc, work. So if we are to go into, and I just closed the reference sheet, that was so foolish. If we go into, for example, quadrilateral or triangle, we are going to see that quadrilaterals take so many values, but all of these values just represent points. So a quad will take a point for the first vertex, a point for the second vertex, the third vertex, and the fourth vertex, and then the computer just plays connect the dots, and it connects those all together. Now, the most frustrating thing for students is the computer does not always understand that you are maybe trying to draw a trapezoid. If you give points out of order, it's going to connect those points in whatever order you give it, so sometimes you'll end up with like a weird crisscross bow. If you have students trying to make strangely shaped quadrilaterals, please make sure you have them maybe write down what they are doing or somehow record what points should be where, so that they understand the order that they're drawing in. The same is true for triangles. It's just a little less difficult to get a triangle that looks crazy, but triangles also do not take in any lengths. They take in three separate coordinate points, 2 numbers each. Again, an x and a y coordinate for each of the vertices of the triangle. Some of the other things that we'll see work very similar to this. Something that students often like to play with is the begin shape function. I usually recommend that they look at this first example here, where begin shape doesn't take in any arguments. This is usually enough to get students going with what they want to do. This begin shape function is telling the computer that we are going to connect a bunch of vertices that are in that begin shape until it sees in shape close. And close is just an argument that tells it to wrap everything back together, close it and make a shape that has a fill inside. You can add as many vertexes as you want, so I could add another vertex at 50-50, and this is going to start making one of those weird wraparound shapes. So now we see it goes in. I could, somewhere in here, make another vertex at 50-50. I could have it go to that point a few times. But this is a good way to make some of those strange shapes. I find that students often want to make stars, or they want to try and make like diamonds. Begin shape is a great place to do that. It does take a lot of guess and check work. This is where students will really want to have that text function that will display mouse X and mouse Y present on their screens. But it is totally doable for students. The next thing that students ask the most is about making curved lines. Bezier can help you make a curved line. This Bezier has a bunch of vertexes that it's using to swoop between, and that is what's making this black swoop. This is another one that I tend to just set students loose for and make sure they understand what those coordinates do. One big difference is that Beziers can either take X and Y, or they can take X, Y, and Z. X, Y, and Z would be a way to make a Bezier a little bit more three-dimensional. The Z is like the back-forward 3D as opposed to the up-down or left-right. What we are really going to focus on now, though, is talking about arcs, because arcs are probably the most useful and one of the most confusing things. So I am not going to deal with all of this syntax for arcs, because as we can see, there's a lot of confusing jargon happening here. We're seeing half pi, we're seeing quarter pi, we're seeing pi plus quarter pi. We're going to talk about why that is in just a second. What I need us to pay attention to is just the syntax. An arc always needs to have the x and y, and that x and y represents the center of the circle you're cutting the arc from. The width and height, which again is that original circle, so I tell students to imagine like a pie or a football if they're drawing an oval, that you're going to be cutting pieces out of. And then we need a start and a stop, which is telling us where on this arc are we going to put the knife in and where are we going to take it out in order to cut our arced piece out of the circle. These last two things, mode and detail, I let students figure out on their own. We don't need to worry about them so much. Mode refers to how the arc will be closed. Chord goes straight across, pi looks like a Pac-Man, and open means that it does not close at all. Detail I have never actually worked with, so if you want to figure that out, you're welcome to figure that out. Now, there's also a very long description of how this works. If your students have not taken Algebra 2, they're going to struggle with this description, and here is why. Most computer science languages work in radians as a default, as opposed to degrees, which is something we're more familiar with. There's a lot of deep math happening here, but ultimately degrees were an arbitrary number that humans picked because 360 is easily divisible and has a lot of good callbacks to the calendar and other things we're used to using. But it came from nowhere. That's just how we decided to split a circle. Radians are something that you can actually prove exists in a circle. And here we can see kind of these conversions where 0 degrees is also 0 in the unit circle, but 30 degrees is equal to pi divided by 6, 90 degrees is equal to pi divided by 2, 180 degrees is pi, 270 is 3 pi divided by 2, and if we go back to 0 at 360 degrees, that is also the same as 2 pi. If that sounded like a lot of gibberish to you, imagine how it's going to sound to your students, and calmly direct them that whenever they are working with arcs, they should be working in angle mode. So the very first thing that I would direct you and students to do if you want to work with arcs, this is also a great time to pause the video, open your editor, and get ready to code along, is to start by declaring that your angle mode is always going to be degrees inside of your setup function. If you just run this, nothing will look like it changed. This is just telling the computer program that anywhere that would be accepting an angle value, to accept that angle value as degrees as opposed to radians. A great way to connect this for students is they are going to be very, very familiar with changing their calculator mode from radians to degrees if they've taken an algebra course. It's the same idea. They might not understand why, again, if they have not gotten up to Algebra 2 or to pre-calc, but it is something that they'll be aware of that needs to happen. So now, down in my draw function, and I'm just going to give myself a little bit of space to work, I'm going to remember that arcs are always x, y, width, height, start, stop, and then I'm going to start coding an arc. So for our purposes, I'm going to have this arc start at the very center of the screen. That's my 200, 200. And I'm going to make this circle pretty big. We will start with an actual circle. So let's make this like 300 by 300. So that's going to be the same width and height, meaning that it's a circle and not an oval. And then let's have our start and stop at 0 and 180. If I hit play, you'll see that I have a big half circle on the bottom half of my screen. Now, the most common question you're going to get from students is, what if I wanted an arc at the top half? That's pretty easy. I just tell the computer to make those cuts in my circle at different places. So instead of starting at 0 and going to 180, let's go from 180 to 0. And now when I hit play, I have a circle going in the correct direction. If I wanted a half circle on one half of my screen, I could tell my computer to go from 90 to 270, or I could flip these around and go 270 to 90. I could also get half circles that are angled by just making sure I keep 90 degrees between whatever I'm typing in as the start and whatever my stop is. So for example, if I put in 100 and 190, oops, that's not a full 90 degrees, that's not working out for me. If I were to put in 300 and 210, let's see what that does for me. Oh, because I'm only doing 90 degrees and not 180. That's silly. 100, 280. There we go. If I keep 180 degrees between what I'm doing, I will get an angled half circle. So again, if I add 20 here, I could just add 20 here, and that would keep the 180 between them. What I started showing you before my math got messed up is that I can also make angled pieces that look like 90 degrees by just keeping 90 between any of my two numbers. So again, if I wanted to add 50 here, I would just add 50 here as well, and it would keep it looking like the same pie piece, just rotating around my circle. This can be super useful. It also does not have to be limited to just quarter and half circles. I can really put in any value I want here. So for example, 20 and 240 will give me like that Pac-Man shape. 20 and 40 will give me a little tiny sliver. And once I have some of these big pieces, I can also adjust how they look by changing some of these other numbers. If I wanted to move the whole thing, I would change these first two, which will move where that center is. If I wanted to change the actual size of my arc, I would change these numbers. So for example, changing the width will make it look a little bit more squished. Changing the height will bring it down. And you can use that to get some cool effects as well. Arcs are not as intimidating as they seem. They can be pretty easy, but they are very confusing because of the numbers that they take in and because of the fact that they immediately operate in radians. Please make sure that you take time to make sure you're familiar with this, and if you do choose to use arcs with your students, make sure that you give them a lesson or some type of a video so that they can also be familiar with how to use arcs and they're not scared of using them. Again, if you have any other questions, make sure you swing by the ICM chat or come to our office hours. Thank you!